Welcome everyone. Thanks for joining us today in person, and thanks to those folks joining us online for the second of our series of 4 talks concentrating on textiles that we've been doing in the fall and continue through into the winter next year. These sessions are presented by our Fibre platform and Kite Creates, and my name is Helen Weston, and I'm part of the Kite Creates and the Fibre team. If this is your first event with us, thanks for finding us and joining us. And if you haven't already, help yourselves to tea and coffee. And stay with us for the networking at the end of the talk. For those who are new, a little bit about Fibre and Kite Creates. Fibre is the first of its kind academic research platform in the field of textile-based wearable technologies, operating here at Kite Research Institute. Its mission is to make care accessible to people through technology by designing and integrating smart textiles across the healthcare system. Kite Creates builds bridges between innovators in healthcare and creative industries, with an aim to merge these and create human-centered solutions for complex accessibility needs. So we hope you'll be able to join us for all 4 events in this series. Each is a standalone talk, but they are intended to build on each other so that by the end of the series, you will have a foundational understanding of textile and material science. So for those online, please use the Menti code for questions throughout the talk, and we'll speak those questions out loud at the end. So I'm delighted to introduce our speaker who will be taking you through this topic. So Dr. Seiful Hoke is a textile engineer and material researcher whose work bridges fibre and polymer science, textile manufacturing, sustainability, and smart technologies. His research focuses on material performance, degradation, and the development of textile-based sensors and actuators for healthcare and rehabilitation. So in addition to his research here, Seiful serves as Vice President of the Institute of Textile Science, ITS of Canada. So welcome, Seiful.
Thank you so much, Helen, and thanks to Kite Creates for having me for the second time. And as you know, the session today is about fabric engineering or science of fabric structure. We're building on from the previous session, which was on the fiber and the yarn engineering. As I can see, some of the returning faces, familiar faces here. Thanks so much for being here one more time. And as you know, I try to start with checking in. Last time we used a animal mood scale, and this time I thought to keep it relevant to textiles. And in terms of the textiles, wool fiber is one of the major fiber in our field. So I thought to pick up sheep, and as you can see here, the sheep is in different mode. It's very energized, as you can see in skull 9. It's daydreaming, as you can see in skull 4. It also curious or daytime dreaming. So personally, I'm feeling between 7 and 9. I want to reflect on my experiences and also energized to go through the session. So now it's your turn. How are you feeling today based on this sheep scale? 1, 2, 3, 4, 5. 5. Okay, I hope you're going to turn out on 9 after the session. So in whichever scale you are, I really appreciate as you are here spending the time with me, and hope you're going to have a very interactive session. I wish to acknowledge the land we operate, the Kite Create Toronto Rehabilitation Institute and University Health Network. For thousands of years, it has been the traditional land of Huron-Wendat, the Seneca, and the Mississaugas of credit. Today, the meeting place is still the home to many indigenous people from across Turtle Island. We are grateful to have the opportunity to work in this land. Also, I would like to do the access check, because here at KITE we understand access to be a shared responsibility between everyone in this shared space. We will strive to create the accessible space that reduces the need for you to disclose a disability or impairment for the purpose of gaining an accommodation. So, is there anything about the space, display, sound, speaking speed that we should address now and address above? Or if something comes up later, even during my talk, please feel free to raise your hand and mention it to me or the KITE team here. We'll be happy to help you. And also you can see a Menti code here, but before going to that, I would like to mention briefly what will be the session outcome. And as in this session, our audience is very wide background, coming from a very wide background. So the basic, I would like to cover the basic of fabric structure, fabric types. So I hope you will have an understanding of basic fabric types and derivatives. Also, you'll be able to link fiber blends and fabric structure to the clothing performance. And one of the important things is considering weathering condition while you develop a product or apparel. And you can scan this code. I have included some material which can be helpful and also relevant to this talk. Can someone check for me if the code is working or if you can access the? It's working. Thank you so much. Also, you have the website name here, uft.me/fabric, so you'll be able to access the material until tomorrow. Another QR code, my apologies, but this would be the last one. I would like to get an idea about the room, and if you know what you are wearing today, you can pick up your tops or bottoms and can see if you can recognize what you are wearing today. So if you go through the QR code, this is not the right Menti code. You have to go through the QR code. My apologies. If you go to the QR code and go to the quiz, it's going to ask you what is the apparel you are wearing today. Different types of fabric, actually. So I'll give a few seconds to scan, and then we'll move to the interactive session. Can we go to the website, Menti website? Yes. Yes. Oh, I responded. Can you press to see the response? Perfect. 1, 2, 3, braided. Okay. That's interesting. Thank you so much for responding, and I hope I'm not going to quiz this one at the end of the session, but I hope at the end of the session you'll be able to know more which fabric you are wearing. And we'll talk about a little bit of braided fabric. I'm looking at some of the people, and you might have the braided fabric in your overall clothing from top to bottom. So we'll talk a little bit. Thank you so much. Can you move to the slide? Thanks. So let's start with the fabric types. The 4 different types you have noticed in the previous Menti code was woven, knitted, non-woven, and braided. So in a wide scale, these are the 4 different fabric types we usually get in the market, and we usually do the production. So first one is woven fabric. This is a SEM picture, but if we do a schematic, it's like the interlacement of 2 different types of yarns. One yarn goes lengthwise and another yarn go widthwise. So the fabric I'm wearing today, this is also a woven fabric. And if you look at your fabric, in most of the cases, the bottom part, the formal pants, are made from woven fabric. And if you see closely, you'll be able to see 2 yarns are interlacing each other. The second fabric is the knitted fabric. If I show the schematic diagram, it creates a loops. And while most of the cases, the people who are wearing t-shirt or polo shirt are made from, or the sweaters are made from knitted structure. And that's why while you try to stretch it, the knitted fabric show you a lot of stretchability. Because if you see the loop or the structure of the knitted fabric, it has a lot of free space in its structure which it can allow to extend. On the other hand, if you go to the woven fabric, it's a straight yarn, doesn't have that much space, so you don't get that much stretchability. So as I said, in most of the cases, the tops, which is like t-shirt or sweaters, are made from knitted structure, and that's why you get a lot of stretchability. The another one is the non-woven fabric. We are in the hospital setting, so the medical gowns or the masks, these are made from usually non-woven fabric structure. And as you can see in this image, these non-woven fabrics are not alignment of the yarn. The yarns are randomly, or the fibers are randomly aligned, and then you get this type of structure. The fourth one is the braided fabric. As I was saying, maybe some of you also have braided fabric. In most of the cases, our shoelace, our shoe string is made from braided fabric, or even in the hoodie we have a string, that also a braided fabric. In the braided fabric, the yarns are interlaced diagonally, and it mostly the ropes or the tubular shape, we get the braided fabric. So these are the 4 fabric types. I will get one by one and describe a little bit. So let's start with the woven fabric. So the woven fabric we see today, or I have a lot of sample here. You might want to have a look after the session, and different structure woven fabric is here. But I wanted to show you a little bit of what is the basic mechanism of manufacturing a woven fabric. My apologies for the ad, but
when it's necessary to draw loom is easily seen from the illustration.
I'll go with the animation one by one. So here, the roller you can see, there's the yarn which called warp yarn. So if I can show the schematic again in my hand, it was 2 different direction of yarn. One in lengthwise and another is widthwise. So the warp yarns are the lengthwise yarn. So all the warp yarns are usually wrapped up in this beam, which is called warping beam. And the second thing here, I will play. This is called drop wire. If you can see my cursor, this is called drop wire. So if any yarn breaks during the manufacturing process, there's the system that detects that there is a fault in the machine.
Yarn coming off the loom beam in a single sheet or whip roll that is designed to maintain a drop wire that serve as, when the yarn breaks, the its own pedal that is this yarn then passes through it and allows the harnesses to control the raising and loading.
Okay, so as you can see here,
the warp yarns.
This is the harness cord. So this what happens, like when all the warp yarns are in longitudinal direction, it creates a gap between different warp yarns so that the weft yarn can go inside. And this is the mechanism where we control different weaving structure. If you want one up, one down, like one longitudinal yarn goes up and then down of the weft yarn or the horizontal yarn, then this is the mechanism or heel shaft that usually controls that design. And after that, this is called reed. When we have the weft yarn go inside between the warp yarns, then the reed makes it the fabric. It beat up the yarn to the close to the fabric system. So
of the work
let you
yarns,
go through the
controls
video.
the width during weaving,
So this is the
performs the beating
red
up
yarn,
of the
which is
filling
called the
yarn
weft
into
yarn
body
or
of
the
cloth.
horizontal yarn.
The point
and-
where the yarn is beaten up into the cloth is called the fell of the cloth. This is the transition point where the yarn becomes fabric. The cloth now winds over the take-up roll, sometimes called the sand roll or press roll, which, when combined with the let-off of the loom beam, controls the number of picks per inch in the fabric. Finally, the cloth is rolled onto a cloth roll. The threading or drawing in of the yarns can be done manually or automatically on
And this is a video from the industrial section. So I'll not spend that much
drawing in
time.
machines.
And if I just show the schematic of what I have, oh, sorry. Okay, I'll skip the schematic. So regarding, as I was saying, the held shaft in the machine is usually controls what is the fabric structure you want to have. If you want to have this type of fabric structure where one yarn goes up to the horizontal yarn and then goes down to the horizontal yarn, this is called plain weave. And the upper schematic is the one repeating unit. So this structure repeats all the fabric and create you the beautiful fabric you can see below. Another common fabric structure in most of the cases, the pants, for example, denim pants or jeans are made from two-leaf fabric structure. So it's just the difference between how much interlacing and the floating of the yarn between warp and weft, or the longitudinal or the horizontal yarn. Another popular fabric structure, woven fabric structure, is the satin yarn, satin structure. As you can see, you have longer floats here compared to plain or twill. And this is another example. If you want to have a good tear resistance in the fabric, the basket structure is two yarns go together up and down. So it gives you more resistance. Let's talk about a little bit about weaving structure and the fabric performance. So the basic recommendation or the requirement for this type of weaving structure is that we want a good strength and the durability of the fabric. Also, the dimensional stability is very important. As you can see in this picture, just after washing, that can happen, and it doesn't meet the requirement of serviceability. Also, how the fabric is conforming in your body is important, which is like drape and flexibility, and also protection and comfort. While we are talking about durability, I'm going to cover this section a little bit later, but in terms of the durability, which is often neglected, but it's a very important property we need to consider while we are using a apparel or the clothing and want to use it for a longer time. Especially it happens during the protective clothing because the fibers we usually use in the protective clothing or the functional clothing, which are very expensive, we need to consider the durability issue seriously. So I'll cover a little bit about the durability issue. So let's talk about a little bit about how different weaving structure can affect the performance. And I just picked few weaving structure and the papers. For instance, here you can see three weaving structure. One is plain weave, which you have one warp up and down. Then you have twill weaving structure, and this is a kind of mesh weaving structure. And if you can see the performance, here they did the tensile test in two different types of tensile tests, like how strong the fabric upon the force. And as you can see, while we are doing lengthwise testing, the plain weave got the lowest performance, while the other fabric like twill and satin has the most strength performance. And if we consider the warp-wise, lengthwise, and horizontally the fabric performance, it also differs. But the interesting point is if you see the plain weave, this one, I hope you can see my cursor, the tensile strength performance for the plain weave in the warp direction or the lengthwise direction is same in the weft direction or the horizontal direction. This is because the plain weave is the interlacement of 1 by 1. So you have same number of interlacement in the warp direction and same number of interlacement in the weft direction. Just reminding you, warp is the lengthwise and weft is the horizontal wise structure. But on the other hand, when we have twill or satin, and it gives you a little bit more floating, and the load can be distributed more well in this structure when you have a little bit of floating. If you go to the next one to talk about comfort, because whatever fabric we are manufacturing, knitted, woven or non-woven, comfort is a very basic property. And if you see three structure here, again, the first one is the plain weave, second is twill weave, and the third one is the mesh structure. And the gray curve, which is F11 or F21, F31, and F41, this all the legend is the plain weave structure. The blue one is the mesh, and the red one is the twill structure. And in all the cases, they expose the fabric in a sweating guarded hot plate. What does a sweating guard hot plate do? You raise the temperature of the hot plate depending on what you want. So usually when any researcher tests this one, they raise it to a human body temperature. And above the hot plate, you keep the fabric. And they wanted to see how quickly the heat can be dissipated so that you don't feel warm inside. And they found that when it is a plain weave structure, the heat quickly dissipated, and that's why you see the low temperature difference for all the plain weave structure here. On the other hand, if you go to twill or the mesh structure, you have a little bit higher temperature difference. That means that the temperature which is accumulated between your fabric and the hot plate is more than the plain weave structure. And why it happens? The first reason is with the plain weave structure, you have more interlacement. It gives you more pores compared to other twist structure of the fabric, which gives you the advantage of more cooling performance than the other weave structure, which is more floating. The third one, so you covered strength, covered comfort, and the third one is about the protection. So I tried to pick the similar fabric structure for all the performance. As you can see, we picked plain weave, twill weave, and the satin weave. And the researcher did a fine element modeling to figure out which structure can give you better ballistic protection. So they tried different bullet magnitude with this fabric, and the fiber, of course, was ballistic protection. And they figured out that the plain weave structure gives you more protection compared to other structure. Again, with the plain weave, with the more interlacement, you have more crimp. And with the more crimp, it allows you to distribute the load better than the other structure. So if I wrap up a little bit about different weaving structure I covered here, it can give you some fundamental things. For example, interlacing and the float you have. And these are the traits that detect the fabric behavior. Second, the strength. High interlacement actually increase your crimp stress, which lowers the strength. As you have noticed in the first slide I showed, the plain weave had the less strength compared to other structure. Also the abrasion resistance. If the fabric is stiffer, tighter structure, which resist wear better than the weave when exposed to floats. And the air permeability defined by vertical porosity, denser interlacing, which reduce the breathability. So it's always about the trade-off between the fiber you are choosing and also the weaving structure you are choosing. But considering the weaving structure I have included here, here I have almost 20 samples, 20 woven fabric, and they are in different structure. Please try to have a look in these fabrics. In some of the cases, 2 or 3 swatch are same fabric structure, just the fiber is different, and you will be able to feel the difference in your hand. And also in some of the cases, you have different fabric structure, and it will give you a feeling how the structure can change the property, at least the visible property of the fabric apart from the color. So before moving to the next section, do you have any quick question? I know there is a question and answer session at the end, but if there is any quick question, I would love to cover. Perfect. Thanks. So I'll move to the next section, which is woven fabric and production. I really like this topic, and I'll be a little bit slow here so that it's easy to capture. Regarding the production, and the picture you can see here is a police officer is wearing a body armor. And previously, the body armor was hard armor with steel plates, but it has been changing since early 1970s, where DuPont came up with their high-performance fiber called Kevlar, and they started development of the lightweight body armor, woven body armor fabric. And they started their field testing in 1975. Within 6 months of the field testing, their body armor was proven effective to protect a police officer who was shot, but was saved by that body armor. Almost in 1 year, there were 17 incidents where the body armor was effective. However, in 2003, there was incidents where the police officer were wearing a similar kind of body armor, which is made from high-performance fiber. The police officer was shot, and he was severely got injured. So one of the things to consider here, in 1970s, they started testing this body armor. In 1975, the first field testing started, and within 6 months to 1 year, all the body armor was found very effective and well accepted. And we got an incidence in 2003. So you have a difference of almost more than 20 years here. What happened? A body armor which was effective in 1975, the similar type of fabric or similar type of fiber, then it's not effective anymore. So it gives us the consideration about the performance over time, how the fabric or how the material is performing over time. Unfortunately, that was not very critically tested before these things came into action. So this gives us a motivation to do some testing with high-performance fabric. We tested 11 different types of high-performance fabric to see how they perform over time in extreme conditions. In terms of extreme condition, these are the fabrics which are very widely used in firefighters' protective clothing. So we did accelerated aging. We consider almost all the conditions that you can experience in daily life of the firefighters. They can be exposed to thermal condition, they can be exposed to UV. We all are exposed to UV. They're exposed to water, but in terms of their work, it's warm water, so we consider hydrothermal. Of course, washing. After every step, every firefighting situation, they put their fabric for the washing, for decontamination, and also abrasion. That's our daily life. And we consider the condition which is relevant to their condition. We did a very in-depth study here. This study generated 6 papers, a lot of talks, but I'll just cover in one slide, 1 or 2 slides to show the result. And I'll just pick one condition here to make my case. If we just look at the green data points here. So in group A, the data point shows comparatively good. You don't have that much reduction in your mechanical performance. For the group B fabric, this is better actually compared to group A. You don't have that much if you consider the standard deviation or the error in the data. It doesn't have that much reduction in its strength. But if you consider group 3, it has more than 50% reduction in its strength just after 50 days of exposing in warm water, and the temperature was like 40 to 90 degrees centigrade in a very bare minimum temperature. So we analyzed all the fabrics, all the fibers to see what is happening there and what's the reason. I'll just show the result of the green data point, and I will show what's the reason. So we did some analysis, and one of the analysis we did is EDX to see what are the chemicals in this fabric which might consider this degradation. All these 3 fabrics are made from high-performance fibers. The fabric which is on the left side, fabric AMI and SB here, are made from high-performance fiber, and with the EDX analysis or elementary chemical map analysis, we did not see any chemical in this fabric which can contribute to the hydrolysis reaction. On the other hand, the fabric which is on the right side, we saw a fiber which has a lot of residual sulfur, which really contributed to the hydrolysis reaction and it make the fabric degrading faster. However, this is the image of the fabric which lost more than 50% strength. So if I mention the data exactly, they lost more than 75% strength just after 50 days. And if you see the fiber, this is in 20 micrometer scale, so in a very zoomed in, and none of the fiber shows any problem. It seems like all the fibers are intact, there is no breakage. Again, you got more than 75% of the reduction. And then that happened with the police body armor. They knew that the body armor looks good. They still kept wearing that without knowing that this is not protective enough. And this actually describes this graph. When you consider about protective clothing, we have two different limits. One is performance limit and another is visual limit. And the performance, based on the research we did, the performance limit get lost before the visual limit. And the space between here, between performance and visual limit, that creates the problem. Then you don't know if it's effective or not. So we moved one step ahead to figure out a solution. This is also we did a lot of work to figure out the solution, but I'll just cover in one slide. So we developed an end-of-life sensor for this type of fabric. We took the example of fire protective fabrics, but this can work for all the fabrics which are made from high-performance fiber that we tested. And to monitor different conditions, high temperature, moisture, and UV radiation, and to make the fire protective fabric or the firefighters know that when the fabric is reached to its unsafe limit. So we developed this sensor here. This is a schematic diagram, but this is the physical sensor we developed on a very simple mechanism. We identified the polymer that degradation perfectly matched with the fabric degradation, and we made a conductive track below the polymer. So the idea is when the people is wearing this type of fabric, they will be wearing this sensor as well. And as the polymer degradation matches exactly with the fiber degradation, we found that their degradation trend is similar. So when the fabric is going to their visual, below their performance limit, the polymer is going below their performance limit, and there will be minor cracks. And with the minor crack, the conductive track, which is the black here and made from graphene, will be exposed, and you will see the difference in the conductivity of this polymer, and that's how we'll be able to know if the fabric is still effective or not. One company in Alberta bought this license, and right now they are just scaling up the product to get it to the market. I hope we'll get it soon in the market. That's in a nutshell about the woven fabric and the performance over time. Do you have any question at this moment before I move to the next section? Okay, so the next section is the knitted fabric. In most of the cases, as I said, the tops part, if it is a t-shirt or the polo shirt, these are the knitted fabric structure. And if I go to the formation of the knitted fabric, this is how the loops are created. So the yarn goes and the needle takes it down. So this is the difference of the, I just wanted to show it again. This is the difference between the woven and the knitted fabric structure. And in terms of the knitted fabric, you have two different types of knitted fabric in a large scale. One is weft knitting fabric. In most of the cases, the t-shirt or the polo shirt or sweaters are made from woven fabric, weft knitting structure, where the yarn travels horizontally, as you can see here on the left side. And the warp knitting is on the right side, where the yarns are interlocked, and that's why you don't get that much stretchability. I'll cover a little bit about the knitted fabric structure and their performance. So here, as you can see here, we developed 3 different types of knitted fabric. One is plain single jersey. On the notation diagram, that's the basic repeating design. You have all the similar kind of loop. Then you have single Lacoste. In most of the cases, the polo shirt is made from single Lacoste. You have 2 different types of loops. One is called knitted loops, and the one which is look like V is called tuck loops. And in the double Lacoste, you have kind of similar to single Lacoste, but another extra layer of knitted loop structure. And this is the technical part for the cam design and the needle arrangement in the machine itself. So we tried to use the similar yarn count for all the fabric, and we tried to use 3 different types of fiber. One is natural fiber, which is cotton. We used regenerated cellulosic fiber, which is viscose, and we used synthetic fiber, which is polyester. So we wanted to see how different types of fiber and how different fabric structure give you the performance. And this is one of the, we did a lot of tests, and this work has been published in 2022. So we did a lot of tests, but I picked just 2 tests here to show you the result. So one is the strength or the mechanical performance. We did a test which is called bursting test. So it gives you the pressure, and with the pressure, the fabric breaks up, and it measures the pressure until it breaks up. So as you can see, in all of the cases, if you see the plain single jersey structure, the fabric which is made from polyester or synthetic yarn gave us the best result, and it's assumable because of the strength of the synthetic yarn. On the other hand, if you go to the single Lacoste and double Lacoste, they have less strength compared to the plain structure. But in all of the cases, the polyester fabric gave the better result in terms of strength. However, if we consider comfort, one of the tests we did how quickly it can absorb your perspiration. So we did a lengthwise wicking test that could be length and width both ways. So we did a lengthwise wicking test, and as you can see, the result is a little bit different than the strength. Here, with the comfort, we found with the plain and simple structure, the wicking is better compared to the structure of single Lacoste and double Lacoste. So because of the more interlacement and more yarn compactness, you get less wicking in this structure. So again, this is really a trade-off between what are the types of fiber you are using, what is the fabric structure using, and what is the main end-use properties you are aiming for. So while we are developing an apparel, we just need to consider, we cannot consider just one criteria, we have to consider the combination of different criteria. If I just conclude this study, the fabric structure, especially single Lacoste and double Lacoste, have a great influence on the bursting strength, as you have noticed in the previous slide. Also, plain single jersey fabric made from all 3 types of fiber shows the highest wicking, as I showed you in the previous graph. And also, tight and compact fabric structure helps to represent excellent peeling grade. So the peeling grade is, in some of the cases, you will notice that there are some peeling in the fabric, which is also another kind of abrasion test. So with the tight structure, you can have a better peeling. Again, saying that what are the types of yarn you are using is also important. In the previous session, I was covering different types of yarn, and if you are using compact yarn, with the compact fabric structure, you are going to have a better abrasion and the peeling resistance. This is another study we did, and this is a very comprehensive study considering the fabrication of the knitted fabric. And this is the first study based on my knowledge on the production of the knitted denim fabric. So all the bottom pants which is made from denim fabric are usually used to be from oven structure. But since last 10 to 15 years, this has been changed, and we are developing jeans pants, even the jackets from knitted structure. However, there was no study, literally no study until this one to show how to fabricate this fabric and scientifically peer reviewed. So we saw this gap and tried to manufacturing a knitted denim fabric, which looks completely like a oven fabric, but coming from knitting structure. And with the knitting structure, as you have noticed with your t-shirt or the tops, sweaters, it has more stretchability. So knits always gives you more comfort and flexibility compared to oven. And that's why actually knitted denim fabric is getting popular. And we did a lot of tests. So one of the aim of this study to see how to produce this type of fabric, and also to show what is the best fiber composition. So as you can see, we prepared 7 different types of knitted denim fabric made from different composition of fiber. We took 95% cotton to 30% cotton, 65% polyester, and 5% spandex. This is very common fiber composition which has been used in industry, and you will be seeing different, if you check the label of your apparel product, you will find this type of fiber composition a lot. Nowadays, you will see a lot of organic fiber included in few percentages, but this is the major buyer requirement while we get the order. And as I showed in the previous slide here, we did more than 10 testing to figure out which is the best. I just picked one here to give an example. The fabric which is called D here, and which is manufacturing from 55% cotton, 40% polyester, and 5% spandex, gave us the overall best result while we compared all the different fiber composition and all the characterization we did. So this is in a nutshell about the knitted fabric and its structure. If you have any questions on the knitted part, I can take it, or you can have the question after. Okay, I'll move to the last part, and hopefully will be covered within 10 minutes. The last one, second last, sorry. The last one is the non-woven fabric. I will not talk about different manufacturing techniques. So we have 6 different manufacturing techniques for the non-woven fabric. And in the hospital setting, as I said, the medical gowns or the mask are mainly made from non-woven fabric. And the manufacturing technique which is used is called spun bonding in most of the cases. So you have the polymer chip, and then you melt the polymer chip in the wave formation with the heat and pressure. Then you get the fabrics. The other 3 types of non-woven structure is the wet-laid, air-laid, and the thermal bonding. As we don't have that much time, I will not cover the manufacturing technique a lot, but I thought to consider presenting another study I did, which is relevant to this setting, hospital setting, is self-decontaminating non-woven. So the motivation of this project is to develop a fabric or the fabric layer which can capture different contaminating agent or the wildfire agent and can decontaminate it on your own. And we thought to use 2 different technology, 2 different idea. One idea, how to capture all the pathogens or all the contaminating substance in the air better. So the first to have a trap in the body, in the cloth, so that it can trap the contamination. And then we have, in the trap, we have the medicine, kind of, which can detoxify your contamination. So we thought to have a filtration of chemical and biological aerosol. And aerosol can be collected by fibrous media. And the nanofiber web is a perfect example. So what happens in the while you do nanofiber manufacturing through electric spinning, it has a electrostatic charge inside, and which helps to capture the contaminating agents. And the best part is that it can capture pores or aerosols which is smaller than the pore size in your cloth. So just consider a normal cloth, for example, the one I'm wearing right now. If a aerosol is smaller than the pore size in my weaving structure, it can go easily inside my cloth and go to my skin and contaminate me. But we cannot compact it, right? If we make it very compact, it is not breathable. Then I have perspiration, uncomfortable situation, right? So that's why I wanted to see nanofiber web, which has the electrostatic charge, can capture things even if the contaminating agent is less in diameter or size than the pore size. It will not be able to pass through our layer. And also detoxifying that agent. We can capture, but also we need to detoxify. And some of the nanoparticles, metal nanoparticles, is really helpful in this region. So we took some nanoparticles to produce that nanofiber. And as I was mentioning, the breathability or the comfort part is very important, and that's while non-woven structure is really helpful. How we did it? So we took two different nanoparticles. One is silver nanoparticle, which is very antibacterial. There are a lot of studies on the efficiency of silver nanoparticle. And we took magnesium oxide nanoparticle, which is also effective in detoxifying. Then we did regular electric spinning process. We did the bathsonication and also stirring for up to 8 hours, and took the solution in a syringe to manufacture the non-open. So this is a small video from library to show how it works. So in the syringe, you have your receiver around 15 centimeter distance, and you flow the solution in a particular speed. In our case, we did it in from 1 to 3 microliter speed, and then you get something like this. So this is what we prepared. And then we did some tests to see how effective it is. But the idea was to have it as a layer in the fabric, so you can have detoxification with a non-open structure. So as I said, the one idea is to have the nanofiber scale as small as possible. So we tried different concentration, and we found that with 10% silver nanoparticle, we get 10 to 15%, we get the lowest fiber diameter. In terms of the magnesium oxide, with 10%, we also got the lowest fiber diameter. So our main aim was to get the lowest, as much as low we can get it. So that fiber diameter we got around 170 nanometer. Also, as I said, like silver is working for antibacterial, and for warfare agent, the magnesium works better. So we did a dual electric spinning. So we have two syringes. One is loaded with silver solution, and one is loaded with magnesium oxide nanoparticle solution. And it showed that there is no contamination between silver and magnesium oxide while we are producing. And also the fiber diameter remained within the range we wanted. Now moving to the next fabric, which is the braided fabric, which is the interlacement diagonally of the yarn, which more than 3 yarn. And then you get this type of fabric on the right side. As I said, in most of the cases, shoestring are made from braided fabric. Some of you might have it already. In the hoodies, you might have a string in the hoodies, which is also a braided fabric. So why the braided fabric? First, for the tubular and complex 3D shape, there are a lot of application of braided fabric in medical setting. Also, it has high resistance to abrasion because of the helical yarns rotate stretch better. And also it has controlled elongation and energy absorption on the direction we want. And there is no crimp. If you remember from the first slide, we had a issue of the crimp which reduced the strength of the plain weave structure. For here in this case, you don't have that much crimp, which help you to have a better strength. So in the conclusion, if I revisit all the slides I have presented, the fabrication technique really defines the function and also considering the other things you are including. Also, the fabric structure and blend dictate the performance of the product, and environmental resilience is very critical while you are developing a fabric which needs to be very functional, and you expect it to have use for a long time for the end user. With that, thank you so much. This is my LinkedIn ID. If you want to get in touch, you can scan the QR code. But apart from that, thank you so much for attending the talk.
Are there any questions? Does everyone know what they're wearing now? Woven, knitted, or?
This may be a disjointed question. Just a little bit too much. Can you help me understand a little bit more about how plastics are embedded within woven systems, and what is the impact of wearing plastic on our bodies, and how do we understand what is plastic works, like polyester plastic versus other Lysol and other components? Is there one that's better than the other? What have you seen?
I didn't get the whole question. I guess the mic is not working. But if I summarize a little bit, you are trying to understand how plastic.
The use of plastic within woven environments and woven clothing, the impacts of this, whether on the body itself, is there a correlation that you found in your research?
Yeah, so the impact is very high because these are the things are not biodegradable, right? While we are talking about plastic or petroleum-based fabric. And regarding the correlation or the chemicals we are using, for example, if I talk about my research, some of the fabric contains PFAS, some of you might know, which is very carcinogenic, and it can go into your skin. But very few of us really consider these things while we are purchasing a product. Or if you are not from the field while we are developing a product, like what could be the consequence later? Not only about the sustainability, but the other, as you said, like skin contact as well, right? So the PFAS is one of the chemicals researchers trying hard to replace that. We don't have that much good result yet, but getting there. Thanks so much.
Anyone else?
Just yell it. I'm seeing when I'm purchasing items a lot more recycled polyester. Is there a difference in performance from recycled polyester versus polyester? Is it all the same?
Yeah, thanks so much for the questions. And if you go through my sample here, there are a lot of brand are made from recycled polyester here as well, the yarn type. But there is a loophole here. While we are developing the recycled polyester, in the fabric label, you don't see how much was recycled and how much was virgin polyester. If you use 100% recycled polyester, it's going to give you a little bit of less performance. And considering from where it is coming is also important. For instance, if the recycled polyester was colored and the decontamination was not removed, it may not be good for you. Just, I can give you one example. As I was saying about PFAS, which is from firefighters' protective clothing, and I did a lot of research there, so it's easy for me to give this example. While firefighters are going to any incidents, they are not exposed to fire, they are exposed to other chemical as well, right? Because of the burning. And their clothes contain these chemicals as well. So if the industry which is recycling this product, if they are not being that much careful, that might be a problem. But I believe all the industries are obeying all the regulation. But if you go through 100% polyester and 100% is like recycled, that might give you a little bit of less performance. But again, it's a trade-off in terms of the sustainability and the thing you are doing by purchasing this product is helping the environment as well. That might be less long-lasting, but on the other hand, you are also helping the environment. Thank you for the question.
Any other questions? Okay. Well, thank you so much, Saiful. Really interesting, and looking forward to the next one.
Mhm.
Push the slide on, it will show you
Oh,
when is Saiful's next lecture, which is mid-January. So hopefully see you all then. And please stay around afterwards for a tea and some snacks. Thank you.
thank you so much.